today I am very excited to present our project called Tetris 2048. This project was born from the idea of merging two iconic games, Tetris, a face-based block stacking game, and 2048, a strategic tile merging puzzle. Our goal was to create a completely new experience that is both strategically challenging and fast-paced, while keeping the spirit of both original games alive. For the project concept, we simply brought together the following block mechanism of Tetris with the number merging logic of 2048. Each Tetramino pieces that falls into the grid is made up of tiles, and each tile holds a number, either 2 or 4, randomly assigned. As the player moves and places Tetraminos onto the grid, two important mechanics happen. Next, please. First, if two tiles with the same number touch vertically after landing, they merge and double their value, like 2048. Second, just like in Tetris, when a full horizontal row is filled, it clears and gives additional points. However, it's important to note that merging tiles always takes priority over clearing rows. This small design decision creates a new layer of strategy. Players must think carefully about where and how they place their Tetraminos. For the game mechanics and rules, there's total 7 classic Tetris shapes, also known as Tetraminos, that the player can move left, right, down, and rotate to fit into the grid. The grid itself is 15 row high and 14 columns width. The objective of the column is twofold. You win by creating a tile that has the value of 2048. You lose if the tiles take up and cross to the top of the grid, and scoring is based on two actions. Merging tiles to create a higher numbers earns you points based on the value of the merged tiles, and clearing horizontal rows also adds to your score, but it has a lower priority compared to merging. For the technical implementation, we implemented the game entirely in Python 3 using a modular and objective-oriented approach to ensure that the code is clean, scalable, and easy to expand in the future. The key components of our code are two main classes. Next, please. Tetramino class. This class handles individual Tetris pieces. It manages the shape, value assignment, movement, left, right, down, and rotation of the pieces. Each Tetramino is represented as a 2D list called a tile matrix, where each element indicates whether a tile is filled or empty. Thank you for listening for my part. Now, my friend Ata will continue for the game grid class.
This class manages the entire game board. It handles Tetramino placement, merging logic, row cleaning, score calculation, win and loss detection, and displaying the grid. We also used std draw library for graphic rendering. It allowed us to draw the grid, the pieces, the score panel, and the message like game over or you win on the screen. This is the slide that I mentioned. In addition, we paid too close attention to user interaction, capturing keyboard inputs, moving and rotating pieces in real time, ensuring smooth and responsible gameplay. Game flow. The flow of the game is simple but dynamic. At the start, a menu screen is displayed, inviting the player to click to start. Once the game starts, a Tetramino falls from top. The player moves and rotates the piece to fit into best position. When a blends any vertical merge happen first, and then full horizontal rows and cleared if possible. The next Tetramino appears and the cycle continues until the player either wins or loses. We also implemented additional logic for removing free-floating tiles. Tiles become disconnected from the main stack after merge or clears. This helps keep the grid clean and maintains fair gameplay. Design philosophy. One of the most important parts of our project was maintaining modularity. We designed our classes and function in a way that allows for future updates, such as adding new tile values, introducing power-ups, creating different difficulty levels based on grid size or tile generation. Because of the clean architecture, it will be easy to extend the game in the future without major changes to existing code base. The challenges and achievements. During the project, we faced several technical challenges. The first one is the implementing tile merging vertically while preserving the falling behavior of the Tetris pieces, handling collisions on and boundaries correctly during rotation and movement. Balancing the game's difficulty is remained challenging but not frustrating. Through the careful testing and code refinement, we managed to overcome these challenges and deliver a fully functional and visually appealing game. We also created UML diagrams for our classes, sequence diagrams for main game loop, and the data structure diagrams to keep our design organized and professional. In conclusion, the Tetris 2048 project successfully merged the strategic depth of 2048 with the fast reflex-based gameplay of Tetris, creating a unique puzzle experience. Thanks to Python, STDraw, and careful modular design, the game is easy to play and visually clean and scalable for future implementations. Thank you all very much for listening. That's our project.
Thank you very much.